Yeah, Assalamu alaikum. Now we are going to talk about calorimetry. This is one of the topic of thermodynamics, very important topic for physics. Calorimetry in class 10th of class 10th in ICSC and ICSC as such. So calorimetry is basically based on in calorimetry we say Q means amount of energy given is directly proportional to mass. Q the amount of energy given is directly proportional to capital T, change in temperature. So we can say Q is equal to directly proportional to m into delta T. If we remove proportionality sign, then we take Q is equal to m into C into delta T, where C is equal to specific heat capacity. And specific heat capacity of water is 4.2 joule per gram per degree Celsius, This is for water, 4.2 joule per gram per degree Celsius. And ice is having specific heat capacity 2.1 joule per gram per degree Celsius. So this is we have, and calorimetry is principle of calorimetry is heat lost by hot object is equal to heat gained by the cold object, and we assume that there is no loss of heat in the surroundings. So heat capacity is is m into mass into specific heat capacity. This heat capacity is also known as heat gradient. So m into C heat capacity, and heat gradient is known as mass into specific heat capacity, right? So and this is denoted by capital C. C, and there is m is equal to mass and C is equal to specific heat capacity. Now we have ice at 0 degree Celsius. Ice at 0 degree Celsius converts into ice water of 0 degree Celsius. Then Q is equal to m into L. Sorry. Yeah, Q is equal to when 0 degree ice converts into 0 degree water, then m into L, where L is specific latent heat. Latent heat of fusion of ice. That is 336 joule per gram, and this is Q is equal to ml. When it's change in state, then there is a latent heat, and latent heat of fusion of ice is 336 joule per gram per gram. And 0 degree ice convert into 0 degree water, and 0 degree water convert into say 100 degree of water. Then there is Q is equal to m into C into delta T. Then there is m into C into delta T. There is and this 0 degree water, this 100 degree water converts into steam of 100 degree Celsius, and again there is a change in state, so Q is equal to ml, that is latent heat of vaporization, specific latent heat of vaporization, that is 2260 joule per gram. So what I told you, that 0 degree ice convert into 0 degree water, Q is equal to ml, that is latent heat of fusion of ice, that is 336 joule per gram for per gram. Then 0 degree, then 0 degree water converts into 100 degree water, then m into c into delta t, and then 0 degree water, then 100 degree water, 100 degree Celsius water convert into 100 degree Celsius of steam, Q is equal to ml, where L is equal to latent heat of vaporization of water. Now we have to discuss, now we will try to solve some questions on this what we have studied here. That question number 1 is like this, that question number 15 we have, and in this question we have there is lead piece, there is a lead piece, piece mass is 400 gram, there is a lead piece of mass 400 gram, mass 400 gram, mass 400 gram, T is equal to 20 degrees Celsius, and T1 is equal to 20 degrees Celsius, T2 is equal to 50 degrees Celsius, delta T is equal to T2 minus T1. T, that is T is the temperature of mixture, that is 20 degrees Celsius, and T2 is temperature of lead piece, that is 50 degrees Celsius, and that comes down, so 50 degrees Celsius come to 20 degrees Celsius, it means there is change in temperature of 30 degrees Celsius. So Q is equal to in this process, Q is equal to 1560 joule. So we can say that heat capacity heat capacity of lead, that is specific heat capacity, sorry, I'll mention here, that is heat capacity of lead is m into c, so Q is equal to m into c into delta T, right? So we can say this is specific heat capacity, this is heat capacity. So since we have to find heat capacity, so m into c is equal to heat capacity, and heat capacity is equal to Q upon delta T. Heat capacity is equal to Q upon heat capacity is Q upon delta T, right? So heat capacity is Q upon delta T, so Q is 1560 joule, that is 3 and change in temperature is 30 degrees Celsius, so we 3 5s are 15, 3 2s are 6, 3 5s are 15, 3 2s are 6, so it is so joule 52 joule joule and temperature degree Celsius. So heat capacity is 52 joule 52 joule per degree Celsius. Now specific heat capacity now specific heat capacity C is equal to M, capital C is equal to M into small c. So this is 52 joule per degree Celsius is equal to M into, for mass is 400, so C, so that is C is equal to 52 upon 400, so it is joule per kilogram per degree Celsius. So this is what we have. Specific heat capacity will be this is 2 2s are 2 2s are 4, 2 6 are 12, 400 divided by 2 are 200. Now again 100 and it becomes 13. So it is C. Specific heat capacity of lead is 0.13 joule per kilogram per degree Celsius. So specific heat capacity of lead is lead piece is 0.13 joule per kilogram per degree Celsius. Okay, so this was the first question we have. First numerical, basically we in maths we are talking this kind of calculation question, and in physics we called it numerical. Since so anyway, now we are going to the moving to the next numerical on physics on the same topic of calorimetry. The question is question number 14 we have. Now so question is like this. There is a piece of metal. This is piece of metal we have, which is having a mass of 550 gram. A piece of metal mass 50 gram temperature is 20 T1 is 27 degrees Celsius. T1 is 27 degrees Celsius, and it on heating T2 is 327 degrees Celsius. Oh my god. By on heating a metal piece of mass 50 gram at a temperature of 27 degrees Celsius on heating reaches to a temperature of 327 degrees Celsius, and energy in this process Q is equal to 2400 joule. So Q is equal to M into C into delta T. Specific heat capacity of metal into delta T, right? So Q is 2400 is equal to mass is mass is 50 gram, and specific heat capacity of metal we have to find, and that is that is 327 minus 27. So 2400 upon 300, 50 into 300 is equal to specific heat capacity of metal. So this is we have now to 3 ones are 3 ones are 3, 3 eights are 24, 8 is coming. Now we have specific heat capacity of metal is equal to 8 upon 50, 8 upon 50. So 50 2 4s are 8, 50 25, then 4 upon 25. So 0.1s are 25 and 25, we get 15. It's 0.16. 25 6 are 150. So specific heat capacity of metal is 0.16 joule per gram per. No, this is wrong. I mentioned. I'm extremely very sorry. It should be 0.16 joule per gram per degree Celsius, because mass is in gram. Unfortunately, I not taken in consideration there. It should be now it is in grams. So specific heat capacity of metal is 0.16 joule per gram per degree Celsius. Mass is in gram because above mass it is given as mass of the metal piece in gram. So this was the specific heat capacity of metal piece. So when we 1000, so we'll multiply it and it will be 160 joule, 160 joule, 160 joule per kilogram per degree Celsius. Sorry. Sorry. Now we have next question. Now we have next question on this principle of calorimetry. I hope you are enjoying. I am trying to do my level best, since when you are speaking, you are writing, you are reading, so there may be there may be some chances of misreading, but the thought process, you put your own thought process, that when mass is in kilogram, then the answer will also in kilogram. Unit conversion will be done if it is required. Now we have question number 7. Very nice. This is the question number 7 we have, and there is given us something like a kettle of power. A kettle of power. A kettle of power 50 watt. A kettle of power 50 watt. 50 watt. So 50 watt. Time we have to find, and P is equal to W upon T. So T is equal to W upon. So we can write W is equal to Q. So so T is equal to W upon. So T is equal to W upon P. And W is equal to M into C into delta T. We have M into C and M into C into delta T. So material material of mass 50 gram, 50, oh my god, material is of 50 kg. Specific heat capacity of metal is 960 joule per kilogram per degree Celsius. And change in temperature is equal to T2 minus T1, that is T2 minus T1, that is 338 minus 38 minus 18 degrees Celsius. 38 degrees Celsius minus 18 degrees Celsius becomes 20 degrees Celsius. So change in temperature is 20 degrees Celsius we have. So there is a material of mass 50 gram, specific heat capacity of 960 joule per kilogram per degree Celsius, and change in temperature is of that was change in temperature is of 20 degrees Celsius, right? 30 degrees to 20 degrees Celsius. Then T is equal to M into C into delta T. T, so 50 into 960 into change in temperature is 20 upon power is 500 watt. 500 watt we have. Power is of 500 watt we have. So we'll put it here 500 watt. So something I went wrong. No, it's not. It's 500 watt. So this is 500 watt. So this 10 is cancelled out by 10. So it becomes T is equal to this 0 cancel 1 960 into 2. 960 into 2 becomes 0. 2 6 are 12. 1 2 are 2 9 2 9 are 18. 190. 1920 seconds. 1000 T is equal to 1920 seconds divided by 60. Then we get minutes. Then 16 threes are 18, 180, and then 12, it becomes 32 minutes. So now 1920 divided by 60, we get 16 threes are 180, 192 minus 180, 12, 0 carry, it becomes 120, then 62 are 120. Now we get 32 minutes. So in 32 minutes this will come to a temperature of from 38 degrees Celsius to 18 degrees Celsius with a power of 50 watt. So this was the solution of question. I hope you understand well, and I try to explain you well in best of my knowledge and experience. So thank you very much for being with me. Have a nice time.